Hello guys, in today's very short video about how to find the frequency at which the power supply that you are testing is working on. For example, for some interference testing, or you just want to do it, just want to use a bit math function in your oscilloscope. In my oscilloscope I have built-in FFT, so if you know every electronic enthusiast should know that the oscilloscope represents signal voltage over time. So it moves from the left to the right, we have time, and from the bottom top, so the x-axis is time and y-axis is voltage. But in FFT function we've got on the x-axis, on the y-axis we have voltage, so the same as in normal mode, but the difference is that on the x-axis we have frequency. So what I built is just some around 8 loops of copper ML wire like that, taped in some places so it doesn't unwind. Then I attached a computer UTP wire and connected it to a simple BNC connector with ARC on the other side, so I can straightly plug it in to my scope like that. I got on the first channel my loop, my probe as we will call it, and on the second channel I have math function, which is FFT, so from the left we have lowest frequency, to the right we have highest frequency, and on the y-axis we have voltage. So straight away, if I will zoom in, we can see that there is some hum on the low side here, which is probably 50 Hertz hum of the mains, which is all around us there. And right now I have some power supply, so I will put my loop around this power supply. And as we can see, power supply makes some noise. So you can see that it reminds us on the last video about power supplies. I have shown that there is a overshoot in the voltage and it turns the transistor on and off, then the snubber network kicks in and stuff like that. So this is pretty similar to the waveform that I showed you. And on the math channel we have a cursor which should show us roughly the frequency at which it operates. So we've got a lot of harmonics, so we can see that it is very not well designed, as I would call it, power supply, because first of all we have a huge interference. It's like we have 50 millivolt per division, and we have here like nearly 1 volt on my 8 loops of wire around, so basically very high interference, no screening, anything, very poor design. We've got 3.1 megahertz here and a lot of harmonics. Of course some low AC hum noise on the low frequencies. So let's right now put it around a computer power supply. So right now we are on the computer power supply for my ASUS. If you want to see how to speed up old netbook, that's a instructable on my instructables. Here we got very low noise, still a bit of this overshoot oscillating thingy because of the inductive nature of the transformer inside. The operating frequency is 3.1 megahertz, so it's kind of the same. Less harmonics, and the whole interference is much smaller. Here we have another power supply, very small interference, and my extension cord has a built-in 5 volt USB ports, and right now I have put it around those USB ports, and as we can see again, a bit of oscillation, you know, inductive nature is there about this power supply, and we can roughly see that the frequency is on the cursors. We can see that the frequency is 3.1 megahertz, same. If I will make the whole thing a bit smaller, we will see that it occurs like that. Of course the FFT doesn't show us this because it's too low frequency, but we can kick in, and as you can see, the frequency on the math channel right now, if I'll put it over there, of this oscillation is somewhere around 3.1 megahertz. So this is an easy way to check if the power supply that you got is working properly, it oscillates properly, and everything works properly. And if it does create a huge interference like this power supply that I have shown you, which is this guy, makes huge interference. It is an LED driver. Huge interference, really don't recommend it. And when you're designing a circuit like that, and the first thing is to make a good product, you should design it the way that it doesn't produce so big amount of interference. We have only 8 loops of wire, and here we have induced nearly 1 volt AC here. 1 volt amplitude peak to peak. So really that's a poor design, and you can see the response a bit of the power supply. So for example, without the load, we can see that the pulses are further away, which is normal because the feedback circuit kicks in that I showed you in the reverse engineering video about the power supply. The thing just kicks in, and as we can see, it oscillates rarely, as I would tell, just pulses of those oscillations. But if I will load it with my lamp here, we can see that the pulses are much closer, and we have this 3.1 megahertz harmonic here. So I hope the video was interesting. It's a bit short today, 7 minutes, something like around, and see you guys next time.